Hey folks, welcome to the Neo4j stream. My name's Will, and today we are taking a look at building GraphQL APIs with Next.js, deploying to Vercel and Neo4j Aura, and a little bit about graph visualization and Neo4j Bloom. So I'll talk a little bit about what we're going to be working on and how all of this kind of ties together. So we're picking up where we left off last time, working with what we called the Lobsters Graph project. So if you remember last time, we used Github Actions to set up a recurring data scrape of the Lobsters API. So Lobsters, I'll drop a link to that in the chat here. Corey says you like the large images and videos. Yeah, I'll try to make sure that I'm zoomed in enough, but definitely shout if things are not big enough. So Lobsters is a social news aggregator. So members of Lobsters can post links to articles, they get upvoted, downvoted, commented on by the community, and then there's this algorithm that sort of floats things of current relevant interest to the top. And so last time we used GitHub Actions to set up this workflow. So GitHub Actions allows us to define some code, some workflows that run anytime there's some event that happens with the repo. So typically this is used for like continuous improvement deployment, running tests, doing a deployment, that kind of thing with GitHub. But we can also schedule these to be on a cron job. So to, in our case, run every hour. So every hour we're using this really cool action called flat data. So this comes from the GitHub team. Flat data allows us to fetch data from a file URL, it's like a JSON endpoint, which is what we're using with the Lobsters data, or run a database query and then check that data into the GitHub repo and then do some post-processing steps on it. So we're using flat data to fetch the newest .json. So these are all of the newest articles. And then we're using another action that I wrote called flat graph. And let me drop some links to this because this is interesting as well. So the flat data project is here. This is what we talked about last time. Oh yeah, Corey says it deleted his first message. Yeah, if you want to send the first message again, I just saw the one about large images and video. So flat data is this GitHub action that we just saw that allows us to fetch data and do some post-processing. And then there's also a VS Code integration and a data viewer, which we didn't look at last time. But this, I think, is really neat. And this enables some really neat data workflows with GitHub Actions. And so I wrote just a really simple, let's see if we can find it in the marketplace. I just wrote a really simple GitHub action called flat graph. Yeah, here it is. That allows you to, in that YAML file where we defined our GitHub action to fetch data, so over here, so we defined a bunch of steps. And so the first step is to check out the repository. The second step is to use flat data to fetch our JSON file. And then we want to import that into Neo4j as our post-processing step. And so we could write a script in like JavaScript or Python that uses the driver, connects to Neo4j, loads this JSON file, and then executes some Cypher query to load the data. So I just wrote a GitHub action that's a wrapper around those steps. So we can just include the credentials for, in this case, the Neo4j Aura instance, the file name that we want to work with. So this file gets loaded and then passed as a parameter to a Cypher query that we define here for how we want to create the data. And so this newest.json file, this gets passed as a Cypher parameter. So here the convention is value. So we just write some Cypher statement that says how we want to work with a JSON object at the Cypher parameter called value. And this runs every hour after we fetch the latest data. So that's what we did last time. And the code for that is here in that repo that I linked. Did I link it? No, I didn't link it. Let me drop that in the chat too. So this is a link to the code that we're starting from. So what we're going to do is start from where we left off. And what I really want to do with this project is I want to show how graph visualization is really powerful when it comes to working with social network data and how it helps us to kind of find insights and explore that data. So I thought this Lobsters data set was a really good one because there's a social element to this. Users have to invite other users into the Lobsters site to be able to post and comment, and we have users interacting and posting articles. So what I want to do is build this kind of interactive graph visualization application that we can use to kind of explore this data and maybe try to find, is there content, articles that are relevant for us? What kind of insights can we have? And so that's kind of the next step that I want to do today is take a look at what kind of out-of-the-box data visualization tools are available. So we're going to look at Neo4j Bloom in a minute here. And then because we want to build a more custom full stack application, we're going to get started on that. I like to use Next.js. And what we're going to focus on today is building the GraphQL API. So for our full stack application that we're going to build using Next.js and React, we want to deploy that out there. And we don't want to just expose our database. So we don't want a React application just talking directly to our database. So we want to build some API layer that is actually going to serve the data, and that will be a GraphQL API. So Next.js, which we'll talk about in a minute, has, because it's a full stack framework, has the ability for us to include API routes, which we can use to build a GraphQL server. So that's the part we're going to focus on today, is building that GraphQL server in Next.js. And then we'll deploy that to Vercel and use that along with Neo4j Aura. So that is the plan. And so Corey's question was curious about how and where to store large media like images and video. Let's say I want to store media attached to the Lobster posts. Is that where Vercel comes in? So for something like that, so we have, actually let's jump over to Neo4j. Yeah, so here we go. So this is our Lobsters data in Neo4j. And so Corey's question is, okay, so I have like a video or some images. Here we have user avatars. That's a good one. So every user has an avatar and there's an image associated with that. So rather than storing the file as, and storing the video, the image as a file in the database, instead what we typically do is just store some reference to it in the database. So here we have avatar URL stored as a string, and the value of that is just the URL for this image file. This happens to be hosted on Lobsters, but typically what we would do is store those in something like S3 on AWS and store a reference to that, or like a Google Cloud Storage bucket, something like that, where we're storing the file in some other service, and then we're just storing a reference to it in the database. Vercel can host static content for us. So we'll talk about what Vercel is in a minute. Vercel is a platform for deploying front-end applications, and it also handles serverless functions to us, which is what we're going to be using for our GraphQL API. So what we could do is check those files and deploy them on Vercel and as static content, and then we have some URL to them. I'm not sure what Vercel's sort of, because Corey's also talking about free services. I'm not sure what Vercel's pricing policy is for static content and file sizes. That might be something to look at. But yeah, I typically am using something like S3, which is not free, but it's pretty cheap as far as file storage goes. You can also kind of get away with storing these things on GitHub, and there's a raw git CDN that you can use as well. Although, since you specifically mentioned free services, but that's typically not great for large files. Cool. Yeah, good question. So, so we have our scraper running. So it's been running for a while. We have a bunch of data in here. This is what it looks like. So we have, here's a user. We have some information about the user. They submit articles. So here's one of the submissions. This is something about OpenGL. So we have the URL to the article that they submitted. So we can take a look and see what that is. And then each article can have one or more tags. So this is specific to Linux and graphics. So we can traverse the graph to find, okay, here are other graphics related articles. And we can see who submitted that. Other submissions from this user. We can also see who invited them, who they invited into the Lobsters network. So digging into graph visualization now. So that's our ultimate goal here, is to build some sort of interactive graph visualization application. And we can see we have some kind of limited graph visualization functionality in this tool. This is called Neo4j Browser. And by the way, this is my Neo4j Aura instance. So if you missed last time, we were using Neo4j Aura, which has a free tier, so we can just spin up a Neo4j instance in the cloud without putting in a credit card, which is quite nice. So that's what we're using here. And the default way that we interact with Neo4j and Neo4j Aura is Neo4j Browser, which you can think of as like a query workbench for Neo4j. So it's really designed for writing Cypher queries. So here we've written a Cypher query starting off just to find 10 articles, and you can see we can kind of click around and visualize things a little bit, but it's really good just for development, good for users that know Cypher. But that's not really the tool I want to use, because I want to build this application that anyone can kind of use and interact with. And one tool that is available with Neo4j and also with Neo4j Aura is called Neo4j Bloom. And Bloom is a interactive tool for exploring graphs visually. So with Bloom, let me zoom in a little bit here. Here we go. So Bloom is really a tool for users that are not going to be writing Cypher. So it's not a developer-facing tool. It is something maybe comparable to like a business intelligence tool, if you're familiar with like Tableau, like in that same class of tools, maybe. I think of it as a bit more interactive and self-guided. But anyway, the point with Bloom is that we can configure, it's called a perspective, so configure how users see the graph, what they interact with, but then Bloom allows us to explore the graph visually with this sort of natural search capability, and kind of clicking around to find the insights we're looking for. So very much not about writing Cypher. So before we jump into Next.js and GraphQL, let's take a look at Bloom so we can get an idea of what kind of functionality Bloom has. So here's my Neo4j Aura dashboard. I have a few different projects going now. Here's this one, Lobsters Graph. That's what I'm looking for. And so we can open with Neo4j Bloom. And then the default username is Neo4j. And then I'll need my password, which I have somewhere over here. I think this is the right one. Let's see. Okay, so Bloom's firing up. So Bloom is available, hosted in Neo4j Aura. So that's another free tier service that's available with Aura, which is quite nice. So we said that with Bloom, we have the ability to configure a few things. So we can configure the perspective, it's called. So a perspective is sort of how things are configured in the visualization. And by default, the perspective is generated from the data in the database. So by default, I don't have to configure anything. It says, okay, you have articles, you have tags, you have users. So these are based on the node labels that were found in the database. Cool. So the first thing we can do here, let's search for a tag where the name contains database. Oh, let's see, tag name. So you see we have this kind of natural language search capability where I just started typing the name of the label and then the property I want to search for, and it gave me the option to now narrow that down to search for nodes with the label tag where the value of the name property is databases. Cool. So I have that here. Hi, Rad. Oh, cool. Yeah, thanks for joining. Oh, yeah, Rad says his first introduction to Neo was one of my videos on LinkedIn Learning. Oh, yeah, that's fun. That was a while ago. I should probably do an updated version of that now. Cool. Yeah. Well, thanks for joining. So we've found the databases tag. And so now what I can do, I can right click on this and let's see if we can zoom in a bit in Bloom. Yeah, maybe that's as much as we want to zoom here. So we can right click on this and say, well, okay, I want to traverse this a bit and let's expand to now show me all of the articles that are connected to this tag database. And I can see these. I can kind of zoom in a little bit and let's find one that is particularly interesting to us. Here's the GQL manifesto. Yeah, that is a good one. Now we can expand out on this one and we can see what user submitted that. So here's the user who submitted this article. Here's another. Oh, here's one that I wrote actually. That's a fun one. I'll be a little biased and expand out this one. So this is actually the write-up of our last stream. So no cost data scraping with Github Actions and Neo4j Aura. So you can see in Bloom we have the ability to see, okay, well, what relationships does this node have? What other nodes is it connected to? We can see the properties. Node also has editing capability built in, so we can edit the graph as well. And this article also has the tag API, so let's expand out to show all of the articles that also have the topic API. So this is a good use of the force-directed layout. So if I'm interested in databases and APIs, I can kind of see, well, anything that is at the intersection of those two, so these two here, those are probably interesting for me. So maps with Django and something about using Postgres at Stripe. Yep, like those sound relevant for me. Cool. So another thing that's really useful in Bloom is conditional styling. So currently all these nodes are the same size. They're colored according to the node labeler, or specifically it's called a category, because we can have a group of labels in a category in the Bloom perspective. But we can configure the styling to take into account property values. And this is really useful when you have a lot of nodes on the screen and you want to just very quickly, at a glance, interpret some information. So that's really useful with graph algorithms, where maybe we've run PageRank and we want the more influential nodes to be bigger, or with community detection where we want to color them according to the community. But let's see what we have here. We have score. So score, that's the voting and commenting algorithm. That's how things float up to the top. So because we're not like ordering things in a table, but instead what we can do is make the nodes with the higher score bigger. So if we click here to configure the perspective for the article category, and we go to rule-based styling, we want to add a rule-based style for score that is going to be a range, and this is going to determine the size. And what's nice here is we have a minimum value and a maximum value, and then we say, okay, for the minimum value, we want to make smaller than 1x, so we'll make these 0.25x, and in the maximum 4x when we get some scaling along that range. And that's figured out by Bloom for us. We can refresh the range according to what's in the scene, which is quite nice. We don't have to go figure out what the min and max values are. Okay, so let's apply that. We'll close this window here. And now I can see, okay, well, here's this article here. This is the database's article that has the highest score in the scene, which is really cool. So this is talking about against SQL. So I think looking at what are some things that are difficult to model in SQL, and that had a lot of upvotes and a lot of comments. Cool, so that's a look at conditional styling in Bloom. We can do something similar with user and karma as well. And of course we can also add icons here. So for users, we can give them a user icon. For article, what would be a good one here? I don't know, like a book? I don't know. Let's see, do we have any article? No article icons. Yeah, maybe like a book. Do we have a book? Yeah, it looks like a book. And tag, what should tag have? Maybe like a bookmark? Yeah, it looks like a tag. So we can add icons. Notice that at different zoom levels, we have more information that comes in. So the icons are nice because at a higher zoom level where we don't have enough room to show the caption, we get the icons. We can see what it is at least. So Corey says, can you export graphs for public viewing from Bloom? So for example, Corey's created a Node Explorer with D3 force layout, and wondering if you want to keep working on it. Yeah. So Corey's question, I guess, is can you kind of share these interactive visualizations that you create in Bloom? Can you like embed them in a web application or like share them on the web? And the answer to that is, oops, the mic there. The answer to that is not really. That's not really something that Bloom is designed for. It's not really a use case that Bloom is designed for. Bloom is good for when you want to give a non-developer, think of like an analyst type persona, someone who's wants to interact with the graph, wants to explore it, but doesn't necessarily want to be writing ciphers. That's where the natural language search functionality comes in. We can also configure, they're called search phrases, where it's basically a parameterized cipher query But the end user doesn't have to think about that in terms of Cypher. They're just kind of adding in parameters to what is otherwise a natural language search. But Bloom is not really designed for something you can like embed a specific visualization in an application. You can do that to some degree. So you can host Bloom on a server and then use an iframe to kind of embed the Bloom application that way. There's also query parameters that you can use for the Bloom URL. So like you can see here, this one is past the connect URL. You can also have a URL that passes it's not called a search phrase, but like the initial query that could be a search phrase. So it could be configured to bring up a specific visualization when it loads. But you can't really create a visualization this way and then say, okay, I want to embed this exact visualization in my application and still have it be interactive. Yeah, that's not really something that Bloom is targeted for. And so, yeah, and there's in this video series on the Bloom landing page, let's see. Yeah, here we go. So there's a video series that Anurag did. He's the product manager for Bloom that he did a while ago. Or I should say he's the used to be the product manager for Bloom. He's now oversees a larger set of tools. This video specifically, number 6, this one talks about integrations in Bloom and specifically using it in an iframe that I mentioned. So you can kind of see here where we have other types of visualizations, so some geospatial, some charts, and then Bloom is integrated in that. So we have a link to Bloom inside some of these like map markers and stuff. So I'll share the link to this page again. That gives you more of an idea of kind of how you can embed Bloom, link to it, and that kind of thing. But yeah, that's a really good question because that's the kind of thing that we want to build with this Lobsters application. We want to include a few more things. Like I think we want to be able to maybe bring up an iframe with the article content. Maybe we want to have some charts in there that show like the most popular tags according to something. I want to be able to have a much more custom built application for what we want to build with the Lobsters graph. And so Bloom is not really geared for that. And so that's why we're going to be building our own full stack application. So I'm going to close out of Bloom here. Let's close this page and let's talk a little bit about what the stack for our full stack app is going to look like. So we have the data in the database, and I said we're going to use Next.js, which is a React framework, and Next.js is really a full stack React framework. So I'll drop a link to Next.js here. So Next.js, it basically takes React and then adds a bunch of things on top of it. So it gives us things like file-based router. So instead of having to figure out how to handle routing, we just create a new JavaScript file and we have a route. So if we create like blog.js, we now have /blog route in our application. It has support for API routes, which is what we're going to look at today, which then when we deploy them to Vercel, Vercel is the company that sponsors and maintains Next.js, but has a hosting platform. So when we deploy our Next.js application to Vercel, those are automatically deployed as serverless functions. So we don't have to think about how to deploy our, in this case, what's going to be a GraphQL API. So that's the first step, is we want to build our GraphQL API. We know that there's a really neat GraphQL integration for Neo4j called the Neo4j GraphQL library. So we're going to use that to build our API layer. And then once we have that, we can then take a look at the front end for our application and figure out what sort of visualization tooling we want to use to get started there. But that front end piece, that's a topic for a further stream. Today, I just want to get the GraphQL API up and running and deployed out there to Vercel. So cool, that's the goal. So next is a really nice starter command line tool, I guess you'd call it. If you've ever used Create React App, or there's even one for GrandStack, Create GrandStack App, we can do that with Next as well. So I'm going to run npx create next app, and this is going to create a new directory in our GitHub repo where our next application will live. I guess I'll just call it Next. So this is going to go fetch the latest version of Next and install that. And we'll install our dependencies. Cool. And so now you can see we have this Next directory. And let's cd into Next and do a yarn dev to start a local server. Hello from Brazil. Hello, welcome. Thanks for joining today. Where is everyone else joining from here? So on localhost 3000 is our development server with this basic landing page. That's kind of the simple landing page that we get with the skeleton app that we created. So let's see what we have. We have this Next directory. So that's where our next application lives. It had a README with some instructions. It has package.json that installs its dependencies, which is just React and the Next framework. We have some config that we shouldn't need to think about today. Brought in a git ignore, which is great. We have some default CSS. We have a public directory. And so Corey earlier was asking about if I want to host some static images, things like that. Can I do that in Vercel? And they would go here in your public directory, and then they would get a route to these files. And here we have pages. So pages, this is where we're going to spend most of our time today. So I said earlier that Next.js has a file-based router built into it. So if we create a file in this pages directory, we then get a route in our application to it. And by default, index.js is up to our Aura instance. So let's first set up kind of just a simple GraphQL endpoint in Next.js, and then we'll add in the Neo4j Graph with Aura. Corey says 100 gigs for the free tier. Oh yeah, so that's 100 gig of, was that like download per month on Vercel, I guess? That's pretty good. Or maybe that's storage. Either way, that's pretty good for the free tier. Okay, so if we look in the API routes, there's some examples here in the Next.js docs, and one of those is looking at GraphQL. So I looked at that earlier and figured out what we need to add a GraphQL endpoint. So let's add a GraphQL JS file. We're going to need to add a few things here. So let's add a few dependencies. So I'm going to install Apollo server micro and the GraphQL JavaScript implementation. So micro is a HTTP framework that works really well with Next. I think it was also built and maintained by the folks at Vercel. And there's an Apollo server implementation of micro. And so that's what we're going to use for the HTTP layer. Apollo server is really nice because we can basically just create type definitions, resolvers, put those together, give those to Apollo server, and Apollo server handles everything for serving that GraphQL schema. So let's bring in the GQL template tag. So the GQL tag, that allows us to tag our, in this case, our type defs, so they get parsed as a GraphQL, those GraphQL type defs. So we want Apollo server micro. And let's start off with some type defs. We'll just create kind of a simple example, just proof of concept here. So maybe just like a user that has, I don't know, an ID or a name or something, and then a single query field. It's going to allow us to get a single user. So pretty simple type defs there. Let me make this a little bigger. Oh, it's too big. There we go. And then create some resolvers. So a GraphQL schema is type definitions. So that defines the data available in the API, and resolvers, which are functions that specify how to fetch that data, or how to, in the case of mutations, how to update that data somewhere, how to resolve that GraphQL request. So for our resolvers, we're just going to create one query resolver, which is going to be pretty simple here, and it's just going to return this really simple user object. Okay, so that's type defs, resolvers. The next thing we need is our Apollo server instance. So let's create that. We need to pass type defs and resolvers. And then the next thing we need to do, this is that the server starts before we return the handler to handle the request. So what we're going to do is say Apollo server start, and that's going to return a promise, which we're then going to await in this handler function that we're actually exporting. So we're going to await starting of the server, and then create the handler once we know that the server is started. And that's going to be kind of, there's a few extra things in here that I'm going to skip that are specific to setting up Apollo Studio, which is kind of like GraphQL Playground, but I think we'll still use GraphQL Playground. Okay, so we create the handler, and then we also need to export a config object that is, in this case, turning off body parsing for the API. And that's just saying that we know how to parse the body of the request coming in, so Apollo server is going to handle that, so we don't need to worry about it. Okay, so there's one other thing. So I was looking at this earlier. I think I saved a link to this. So Apollo Server 3 now by default not include GraphQL Playground. So GraphQL Playground is like a query workbench for GraphQL. So it allows us to look at the schema to write GraphQL queries, gives us autocomplete. So it's really handy for testing and development when we're working with GraphQL. GraphQL Playground has been deprecated, so Apollo server does not include that, and they instead link out to Apollo Studio, which is like a hosted version of a GraphQL query playgrounds. But I like to use Playground. I'm familiar with it, so we can add a couple of things to in Playground. It's now available as a plugin, so I'm going to do that. So let's say Apollo server plugin landing page GraphQL Playground from Apollo server core. And then when we create our Apollo server instance, I'm going to say playground true and pass our plugins, the Apollo server plugin landing page GraphQL Playground. Hopefully I spelled that right. Okay, let's start this up and see if that works. So with Apollo Server Micro, like what we're using. And basically what it does is we give it type definitions that define the data model in the database. So we can basically look at our database and see what labels and property types we have, create type definitions that match that, and we then get a fully functional GraphQL API backed by Neo4j that can interact with our database. So it generates all of the query fields, all of our mutation operations. There's authorization built into it. So really, really powerful. Also includes the ability to define custom logic with Cypher, which is super neat. So it's a tool in the toolbox that I am usually very excited about. So that's what we're going to use today. And to get started with that, we are going to add a couple of dependencies. So let's add Neo4j GraphQL and Neo4j driver. So Neo4j driver, this is the Neo4j JavaScript driver that allows us to send queries to the database and interact with Neo4j using Cypher. In this case, we're not going to be writing Cypher. The Neo4j GraphQL library is going to be generating Cypher, but it uses the driver, the Neo4j driver, behind the scenes to talk to Neo4j. So we just kind of have to set up the driver, hand it off to the library, and then we just kind of forget about it. Okay, so we installed that. So let's take out, well, I guess first let's import the Neo4j driver. And let's import the Neo4j GraphQL class. I guess we should set up prettier or something for formatting. That's okay though. Okay, so I'm going to tear out our resolvers here. We do not need the resolvers. That is always very fun. We can just delete those. Our resolvers are going to be generated for us from these type definitions. To node labels. So where we say type article in GraphQL, that is defining a node with the label article. And then fields in GraphQL become properties in the Neo4j database. So in this case, for articles have an ID. They have a URL. That'll be a string. A score, that's an integer. A title, which is a string. Comments, so this is the URL to the comment, so that's a string. And then a created property, which is a datetime. And with the Neo4j GraphQL library, we can use datetime and point. Those get added and mapped to the native database date and spatial types. Okay, what else do we have? We have user. So user has a username. That's a string. User has also a created datetime field karma. Karma is going to be an integer. About, that's a string. And the avatar, that's the URL for the user's avatar. Okay, and then a user, so the graph by, maybe we'll just do that to keep it simple. So a user was invited by another user. And with the Neo4j GraphQL library, we use schema directives, and in this case, a directive called relationship to model the relationship type and direction in Neo4j. So in this case, we're going to say the type is invited by, and the direction is going to be out. So I was invited by a different user. Okay, and actually, is that right? So I have a user who is invited by another user, and I have this invited by relationship that's going out. So if this is me, the direction is invited by out. Yeah, that's right. I don't know why that was didn't seem right in my mind. But okay, users also are submitting articles. So let's call this field articles, and this is going to be a object array field because I can submit multiple articles. This is going to have a relationship directive. The type is submitted, and the direction is out. So these are articles that this user submitted. And then an article, let's call this user. So a single user submits an article. One thing that's nice about the relationship directive, we could just map the type and call that the field name for the relationship, but having this relationship directive allows us to keep the conventions of the two different languages. So with GraphQL, we typically use lowercase for fields in property graph model. In Neo4j, we typically, for relationships, are using uppercase. So this allows us to keep those two conventions. And the direction for that is going to be in. User submitted an article. And then the other thing we have here are tags. So So a tag just has a name, I think. Yeah. And then a tag is going to be connected to articles. That also is going to be an object array field. And what did we call that? Has tag. So an article has a tag, so that's going to be direction in. And then for the article, let's say article has tags. And the relationship type is has tag, and direction is out. Okay, so those are our type definitions. We removed the resolvers because we don't need those. But what we do need to do a couple of things. First, we need a Neo4j driver instance. So driver, Neo4j.driver, and then this is going to be the URI, so something like this. But we need this for our Neo4j Aura instance. And then we need our username and password, which is something like this. Now, I don't want to just hard code these values in, so let's set these up as environment variables. With Next.js, I can just create a .env, call it .local. And here I can set environment variables. We don't need the extension for that. So let's create a Neo4j user environment variable, a Neo4j process.env.Neo4j URI. This is going to be Neo4j user, and this is going to be Neo4j password. Cool. Oh, and then let me actually set the password. So I'm going to do that off screen just so that I'm not sharing my password with everyone and someone doesn't go in and, I don't know, delete all my articles or something like that. So give me just a sec to do that. Okay, on that. Cool, and then I don't think we need to change anything else. Do we? No, I think everything else should work. So let's do a yarn dev and fire this up. But we'll see also we might need to add some custom logic when it comes time to build out the front end. So that's probably a good point for the GraphQL API. We could add some other things using, say, like the Cypher directive to add some for the Cypher directive. What kind of custom logic we might want to add to this API using Cypher. We really have the ability to define any logic here, really using Cypher, and add that to our GraphQL API, which is super powerful. Okay, so what do we need to do next? The next thing we need to do is deploy this to Vercel. So Vercel, let's go to vercel.com. This is my dashboard. I just want to look at the website. Can we do that? We can look at the docs. So Vercel is a hosting platform that allows us to deploy web applications, static content, serverless functions. There's lots of things we can do with Vercel. Vercel, again, they built and maintain and sponsor Next.js. So there's lots of really good Next.js integrations with Vercel. So action running every hour, and so I didn't pull down immediately. So let's pull down the latest, and we'll do a merge, and then we can push up. Okay, so we've pushed that up to GitHub. So if we go to the repo, now we should have, yep, here's our next directory with our next app. And so now what I want to do is in Vercel, create a new project from a Git repository. So I've already connected Vercel to my GitHub account, so it knows all about my GitHub repos. Okay, and says, do we want to create a team? No, I don't think we need to create a team. I think it'll just be me working on this, so we'll skip that. So configure the project. It is a Next.js app. And we need to change the root directory because we have our next app here in this next directory. So we're going to have some other things, like we have our Github Actions workflow, which we don't want Vercel to have to think about. So our root directory is the next directory. And then build and output settings, don't need to do anything there. And then environment variables. So we created some environment variables in the .env.local file. And so those were not checked in to GitHub. So those could be like our development environments. And now we need to set those for our production, for the one we want to deploy. So we need to add some of those here. So we had Neo4j user is Neo4j. We had Neo4j URI, which I have over here. Preview build. So if we have a pull request, we can build and deploy pull requests and then send someone a link to that, and they can then play around with it before then switching that over to production, and then that is just hosted on the production URL. So that's a really nice feature of Vercel. So it looks like it deployed our application. Let's go to the dashboard. And here's the URL for it. So let's open that. So yep, for the front end piece of it, we didn't change anything. So we just have this super simple welcome to Next.js. But what we're interested in is /API/GraphQL. And oh, we got a 500 error. Let's take a look at the logs. So we want the function logs. Cannot find module ts tiny invariant. Oh yeah, so I saw this error, and I think what this is, I saw this previously in another project. I think what this is that there's a bug somewhere in what is it called, the tree shaking issue that Vercel tries to do. So it thinks if you're not using some code, then it doesn't deploy that. And I think there's some issue here with that. So where it didn't actually deploy this ts tiny invariant module to our serverless function, but then something in Apollo server is actually trying to use it. And I saw a GitHub issue or something that had the fix for this, but I think we can do a workaround basically by just importing the package here, even if we don't use it. I think that we'll get around our bug here. So let's add, I think this is just a temporary bug. I think this is something that has been seen and addressed. Fix serverless function error. And we'll push this up. And hopefully our GitHub action didn't run again and we have a merge conflict. Nope, we don't. Cool. And API/GraphQL. And we should see Graphql Playground. Nope. Another 500 error. Let's take a look at the logs. Functions, there we go. Unknown scheme, Neo4j. Oh, so that looks like a typo when I set the environment variable. That's not good. Let's edit that. So my environment variables, it's the Neo4j URI. Yeah, I left off the in. Okay. Let's fix that. And then I think I'll need to redeploy this so that it picks up the change in environment variable. So this is going to build again. Oh, Corey says he's back after some bandwidth issues. Cool, no worries. Thanks. Glad you made it back. Yeah, I've been having internet issues as well, it seems like. So not sure what's going on these days. Okay, so I think that redeployed. Let's try this again. /API/GraphQL. Still got an error. Let's look at our logs again. Unknown scheme. Oh, did I not? Maybe I didn't wait. Maybe I didn't actually redeploy it. Oh, it's still building. I was impatient. Okay, I think it's done now. API, oops, not Neo4j, GraphQL. There we go. So now we've got Graphql Playground. And oh, I think I know what the error is here. I think that we did not enable introspection. So Apollo server looks at the node env environment variable, and when we're running locally and we're not in production, so when we're in development, Apollo server will enable introspection. But once we've deployed something and we're in production, then by default, it does not allow introspection. And so GraphQL Playground needs introspection to be able to render the docs. So I think we just need to, in our case, like I don't have anything secret here in API, so Playground is always going to be enabled. I just also need to enable by created in descending order. This should give us the 10 most recent articles. Oh, let's actually also get the created date so we can make sure. So these should have all been submitted in the last hour. Yeah, that looks right. So Great. So here's the URL for that. I'll drop this to the chat. So this API should be public now, so anyone should be able to access that and write some GraphQL queries. Cool. So the code is on GitHub. I'll link that as well. We'll do a write-up of what we built today. But just to recap a bit, we looked at the Lobsters Graph project, where we're scraping data from the Lobsters social news aggregator. And we built a GraphQL API using Next.js API routes. We deployed that to Vercel, and now we have a public GraphQL endpoint for querying Lobsters data hosted on Neo4j Aura. And the next step is to, I guess, take a look at the front end piece of our application. So I said I want to build this application that's based around interactive graph visualization that can help us explore this data set and find some insights in that. So that's the plan. We will pick up from where we left off next time. And thanks for joining today, and we hope to see you